Okay, so let's to solve the LeetCode daily question 1269, which is number of ways to stay in the same place after some steps. And in this, we'll be given a pointer which is pointing towards the index 0 of an array of size array length. Okay, and at each step I can move either one position left or one position to the right, or I can stay at the same place, and the condition is that the pointer cannot be outside of the outside of the array. Okay, and in the function I'll be given two integers, steps and array length, and I have to return the number of ways such that the pointer will remain at the index 0 after exactly the number of steps have been performed. Okay, so now let's understand the test cases. So in the first test case, let's say I'm having an array of length 2. Okay, so let's draw an array of length 2. Okay, and this will be the 0th index, and this will be the first index. Okay, so now I am having three steps. So the question says that the pointer cannot move out of the array. Okay, so in the first case I can go to the right. Okay, if I go to the right, then I come to the left. It means this is first step, this is second step, and the third step is I could stay. Okay, this is the counter one. Like in one way, I am reaching back to 0th index while the number of steps are still same. Okay, or otherwise, what I can do, I can go to the right, then I can stay over there, and then I come back to the left. In this case, also only three steps are done. Okay, so now current counter of total number of ways we can do this is 2. Okay, so okay, let me add yeah, current ways, okay, is 2. Okay, I'll be always okay. Yeah, okay, but in other way, what I can do, uh, I can stay over here. This is the first step. Then in the second step, I can go to the right, and in third step, I come back to the left. This is another way of doing this. So now the current counter is 3. Okay. Uh, okay. Or the other way, what I can do is okay, it's changing the hat. Okay. Or the other way which I can do, uh, sorry, is okay. Let me use the eraser. Yeah, I can, in the first step I can stay over here, in the second step also I can stay over here, and in the third step I can also stay over here. Okay, so this makes our current counter as 4, and there is no other possible way of doing this. Like if we go right and then again I go right, that makes me out of the bound index. I cannot go left because it's uh, out of bound for the array. And so this is basically what the question states. Similarly, in the next test case, we'll be having an array length of 4, and we can only perform 2 steps. So the total number of ways to stay at index zeros after 2 steps is only 2, which is that. Okay, let me draw the array once again. 1, 2, 3. Okay, so this is 0th index, first, second, and third index. Okay, so I'm having only one way. That one way is if I go here, then I can come back. I can go to go left because it's index out of bound, or the other way what I can do is I can just stay and stay. I cannot perform any other option. There are no any other possible ways through which I can do this. Okay, so now let's move to the pseudocode for this question. And okay, so let's have a DP array, 2D DP array basically. Okay, I don't know why I write int. Yeah, let's have a DP array and we'll be declaring it globally. Okay, and then also have the variable. Okay, no, just the DP, and the question states that the function numBase. Okay, in the numBase function, we'll be having two parameters, steps and array length. Okay, so let's initialize the DP with of size array length and steps plus 1. Okay, and then we'll be just fill dp with -1. Okay, and then we'll simply return the solve function with 3 parameter steps. Okay, with 3 parameters. Those will be index, number of steps, and array length. Okay, array length. Okay, so then what I can do, I can write the solve function which states that I'll be having an int index. Okay, then number of steps, let's call it remaining. Okay, we'll be having the remaining steps and the array length. Okay, then the base is that if remaining, that means that we have completed all the steps, if remaining equal to 0, and also index, if index is also equal to 0, because the question state we need to stay at the 0th index only. Okay, then what we can do, we can return 1. Okay, otherwise we'll be checking the condition that if dp index remaining is not equal to -1, we'll be just returning dp index and remaining. Okay, so now here comes the main tricky part, that for every index we'll be having 3 choices to make. So what we can do, let's have a variable count. Okay, count. Okay, then the first way of doing this is we can just simply stay over there. So what we'll do, we'll call the function solve with same index, and the remaining steps will be -1. Okay, then I'll check that if index is greater than 0. Okay, I can again do that count plus equal to solve. So if the index is greater than 0, what I can do, basically for the 0th index I can move to the right. So what I'll do index. Okay, here it should be index, not the current, it should be index. Okay, what I'll be doing, I'll be just simply doing index plus 1 and then remain -1. Okay, otherwise what I can do, I also have one choice of moving that left, that if index is less than array length, what I can do, count plus equal to, let's solve index -1 array length. Okay, I guess I made a mistake over here. Here it should be that if it is greater than 0, then if it is greater than 0, then I can move to the previous index, and if it is less than, then I can move to the next index. Array length -1, because if I do it simply with array length, okay, I guess, yeah, here it should be -1, because while doing it with array length we might go out of bound, because we need to do it up to the last index. Okay, index plus 1, and then simply, here I also need to pass parameters as array length, sorry, array length, and here also array length. array length, then here remaining -1, -1, and then again array length. Okay, so and at the end what I'll be doing, return dp index remaining equal to count. Okay, so this is the pseudocode. Now let's code it. Let's first declare a dp array, int dp. Okay, and the question that it is also given that we might need to do the mod, because the answer, so let's declare the mod also, int mod equal to int 1e9 plus 7. Okay, it is already given in the question that 10 to the power 9 plus 7. Okay, so now let's initialize the dp with dp would be equal to array length. Okay, sorry, new int array length, and here steps plus 1. Then arrays also for int I in dp arrays dot fill I comma -1. Okay, then just simply returning solve 0 comma steps comma. Okay, let's declare array length globally only, because we don't need to use it again and again, otherwise it will increase the space uh, of when we'll be calling the function. So this dot array length would be equal to array length. Okay, so now write the code function, solve function. We'll be declaring it private, and solve int index comma int remaining. Okay, so then if remain is equal to 0, then I'll check that if index is equal to 0, I'll be returning 1, otherwise I'll be returning 0. Okay, so then the case that if we have already calculated that if dp index remain is not equal to -1, return dp index remain. Okay, then let's have a count variable, count equal to solve index would be the same comma index would be, then okay, remain -1. Okay, then if index is greater than 0, simply update count plus equal to okay, I can't, because I need to take the mod count plus solve for index -1 comma remain -1, and then it's solve mode. Then similarly that if index is less than arr length -1. Okay, arr length -1 basically because so that we can move to the next index also, because okay, let's say we have an array of length 4, 1, 2, of size 4 basically. So if we are at this index, that this means that length of is 4 and 4 minus 1 is 3. Okay, array length minus 1. That this is 0, 1, 2, 0, 1, 2 index. So for this if condition, it will be true, and we will be able to move to the next array. If we basically do array length, here if I do less than array length, we can't go to the next index, as it will give us index out of bound exception, because there will be no fourth index for that. Okay, then count equal to count plus solve for index plus 1, and then remaining minus 1 mod. Okay, so at the end I'll be returning dp index steps equal to count. Here it should be count. Let's submit it. Okay, give you compilation error. Why? Legal. Oh, okay. Yeah, mistake. Yeah, this should work now. Cannot find symbol. Oh, here remain, okay, not steps. Yeah, and this works. Okay, now let's submit it. So it gives memory limit exceeded. Okay, so as we can see that this, okay, but I doubt that this should pass, because okay, now let's check it once again. We declare it memo dp equal to array length and set this one, and for okay, this is fine. Till here it is fine. Then the solve function, that if remaining equal to 0 and if index is equal to 0, we will be returning 1, otherwise we'll be returning 0. Then I do that if dp index remain not equal to minus 1, I do return dp index remain. Okay, then count. Do I need to do the mod here again? Will this help? Okay, I guess this will not. Okay, as you can see that this is given me memory limit exceeded, which basically means that while running the question, while running all the test cases, that stack is getting overflowed, and like we are having fixed memory in stack, uh, but the memory is exceeding. So what we can do, uh, okay, I guess we need to go with the tabulation solution. Here it is running properly. Count equal to count plus mod. Okay, let me try doing one more thing. Let array length is equal to math dot minimum of steps and array length. Okay, so I guess okay, this is accepted. And wait a second, I'll tell you the logic. Yeah, and this gets accepted. Okay, so let me tell you what I basically did here is that when okay, let me write it first. Let, here, okay, let me have a new whiteboard again. Text. What I basically did is array length should be equal to minimum of steps and array length. Okay, because in the question we are given the constraints that steps will be less than or equal to 500, but the array length might go up to 10 to the power 6, which means that the space it will be consuming will be a lot. So that's why we'll be using okay, so let's say we are having 500 steps, and maximum where we can reach is after even moving all the steps to the right, we can just go up to the 500th index. Other than that, okay, let's say let's do it in this way, that if I'm having an array of size 5, okay, and steps, okay, let me write this, that if steps is equal to 3, that if steps is equal to 3 and size of array is equal to 5, that I am having only allowed to move 3 steps. That is, if I go, this is one step from 0 to 1, 2, 3 and 4. Okay, so if I go from 0 to 1, that is one step, 1 to 2, that is second step, and if I go from 2 to 3, that is my third step. Okay, so I'll never be able to reach the fourth and fifth index because the maximum number of steps I can take is 3 only. So that's why while choosing the array length, what I did is I'll simply do the minimum of 3 and 5, because that is where the maximum where I can reach even after completing all the steps. So that's why what we'll do, like in a test case where we'll be given 10 to the power 6 size of the array, and as we can see that the constraint says that the steps will be limited to 500 only. So that's why I'm minimizing the length of the array to up to 500 steps only to find it in a better way. Otherwise, it will give a memory exceeded error. Okay. So now let's move to the tabulation solution for this question. Okay, we'll be again declaring a DP array of size array length and steps, and then simply we'll be setting DP 0 0 equal to 1, then for loop for int remaining number of steps equal to 1 to remaining less than equal to n. Oh, here it should be steps plus 1, sorry, steps plus 1. Okay, remaining less than equal to n. Do it like this. Yeah, why it's not working? It is. Yeah, remaining less than equal to n, and then another for loop for int index equal to array length minus 1. Okay, here I forgot that array length should be again minimum of steps and given array length. Okay, so okay, 2 length minus 1 to index greater than equal to 0. Okay, and then again we'll be having 3 choices to make. So let's give it a variable count would be equal to dp of current, because we'll be staying in that particular dp of index, and here we'll be moving to the previous step, dp remain -1. Okay, then we'll be checking that if index is greater than 0, again what I can do, I can do count equal to count. Okay, count equal to count plus dp index -1 and remaining +1. Okay, then if index is less than array length -1, what I can do, I can do count equal to count plus dp index +1 and remaining -1. Oh, okay, here I guess should here it should be remaining -1. Okay, then after that I'll be doing dp index remaining equal to count. Okay, and after that, after both the for loops are executed, I'll be returning dp 0 with steps. Okay, so now let's code it, reset it. Okay, and now let me zoom in. Okay, so let's have a dp array. First things first, array length equal to math dot minimum of steps and array length. So I'll advise you to always go through the constraints for at least once, because it gives us a brief idea of how we can use the do the space optimization and everything, and what are the things that we need to take consideration. Because if my let's say the steps would have been also a bit more, so that might not have been created a problem, but in this case, as you can see, it created a problem. Even after our logic was correct and everything was correct, it still gave us memory exceeded error. So always keep in mind these things. Okay, and then let's declare a dp array, and dp equal to new and array length, and then steps +1. Okay, again I need to take the mod, so mod will be equal to int 1e9 plus 7. Okay, so then for loop for int remain equal to 1, remaining less than equal to n, remaining plus plus, then for int index equal to array length -1, then while index is greater than equal to 0, index minus minus, what I'll be doing, I'll be having count variable count equal to dp, I'll be at the same index and I'll just be reducing the steps. Okay, then if index, okay, if index is greater than 0, what I'll be doing count equal to count plus dp index -1, and then remaining, so here it should be remaining -1, remaining -1. Okay, then if Oh, here I need to do the mod also. Mod. Okay. Then if index is less than array length minus 1, then count will be equal to count plus dp index plus 1, and then remaining minus 1. And then here I'll be needing to do the mod, then dp index step remaining would be equal to count. Okay, so after this for loop we'll be just returning dp 0 with number of steps. Okay, so I guess this should work. Compiler less than equal to, oh okay, not n, here it should be steps, my mistake, sorry. Okay, it's no, that's 0. What's the issue over here? It's like it's not getting updated or something like that. Current equal to 0, dp minus 1, dp. Oh, okay, here I need to set the value of dp 0 0 equal to 1. Okay. Yeah, it gets accepted, so now let's submit it. Yeah, and it works fine. So we can, what further we can do a space optimization also in this. So let's move to the space optimized solution to this. Okay, let me create a new whiteboard only. Yeah, let's have a dp array. First again, array length would be equal to minimum of array length comma steps, then dp would be equal to the size of array length, and then we'll be having a pref dp. Okay, array length of size array length, and then what we'll be doing, we'll be setting pref 0 equal to 1. Then again the same for loop, remaining equal to 1 to remaining less than equal to steps. Then we'll be initializing the dp again with of size array length, then for index equal to array length minus 1. What I'll be doing, remaining index greater than or equal to 0. Okay, so then dp okay, now firstly the count variable, count would be equal to if we don't move anywhere, then the remaining steps would be seen in pref index. Otherwise, count if index is greater than 0, again that count would be equal to count plus pref index minus 1. Then if index is less than array length minus 1, what I can do, I can do count equal to count plus prev index plus 1. Then after that I'll be doing simply dp index would be equal to my count variable, and then after the first for loop, inner for loop, I'll be moving prev equal to dp, and then just simply exiting the for loop, and at the end I'll be returning dp 0. Okay, so let's code it, and if I try to, okay, yeah, confirm, reset it. Let's have the mod again, mod equal to int 1e9 plus 7, then array length would be equal to minimum of steps and array length. Then let's have a dp equal to int of size array length, then again prev dp equal to new int of size array length, then setting prev 0 equal to 1, then for and remaining equal to 1 to remaining less than equal to steps remaining plus plus, then dp equal to new int array length, reinitializing the dp, then for loop and index equal to array length minus 1 and index greater than equal to 0, index minus minus, then count variable equal to prev index, then if index is greater than 0, what I can do, count would be equal to count plus prev index minus 1, and then doing its mod, then if p, I guess, yeah, then if index is less than array length minus 1, what I can do, count equal to okay, let's have the parentheses first, count plus prev index plus 1, and then do its mod. Okay, then after the inner for loop, I'll move prev equal to dp, and then after this I'll be returning dp 0. Okay, so okay, again wrong answer. Did I just not declare prev 0 equal to, yeah, I did. Okay, then again prev should be equal to array length remaining equal to 1, remaining less than equal to steps, remaining plus plus dp. Okay, here index current equal to array length minus 1, then index should be greater than equal to 0. Okay, that if okay, oh sorry, I'm never updating that if then dp index will be equal to count. Sorry, my bad. I was never updating the dp array. Yeah, now it's worked fine. So let's submit it. And yeah, its time complexity is even faster, and also it uses less memory. So this was it for today. Thank you for watching.